A very warm welcome to everyone present here. I am K. Vishnudasan from Amartya Vishwavidyapitham, Chennai, and my teammate Shiva Prasad. He also belongs to same college. Today, me and my teammate are going to demonstrate a project microwave oven done during the internship at Emertxe. Let me start this presentation with the topics learned during the internship. During the first week of the internship, we have learned about C programming language and its conditional structures like if else, and loops like for loop, while loop, and basic arithmetic operators and logical operators, etc. We have learned about arrays and pointers and how to implement it using the code. And we have learned about various functions and strings, storage classes like storing it to RAM and ROM. And we have learned about the introduction of embedded systems and microcontrollers and the uh, difference between microcontrollers and microprocessors. And we have learned about several softwares used during this internship, which is MPLAB XID, XC8 compiler, and PICSIMLAB simulator. Then we have learnt about the various external peripherals used by PIC 16F8778, and we have learned the various peripherals like keypad, LCD, uh, which are compatible with PIC 16F877. And we have come to the conclusion of the internship by a Disha workshop where we have learnt about soft skills and resume building techniques. My friend Shiva Prasad will explain the uh, theoretical insights gained during this internship.
Hello everyone, this is Shiva Prashant from Amrita Vishwavidyapitham. Today I am here to discuss about what we learned in our lectures and what are basic concepts of embedded systems. Actually, what are embedded systems and what is microwave oven and basic requirements of microwave ovens and difference between microcontroller and microprocessor and what are the peripherals used in microwave ovens and at last my project implementation will discussed by Vishnu Dasan, my teammate, and we'll see about what are embedded systems. Embedded systems are specialized computer systems designed to perform specific tasks or functions within a larger system. Embedded systems are used the communication ports to transmit data between the processor and peripheral devices. Actually, basic about embedded system, it is the combination of software and hardware which is used in our real life. It is a real-time operating system that supervises the application software and provide mechanism to let the processor run a process. A long process, a combination of hardware and software called embedded system. Actually, embedded system, it comprises hardware and software that work together to perform specific tasks. It rely on microprocessor, microcontrollers, memory unit, output, communication interfaces, and power supply to functions. Next, we'll see what is microwave oven, what we learn in our lectures, what is the project given to us. A microwave oven is a kitchen appliance that uses microwave radiations to quickly and efficiently heat or cook food. Actually, microwave oven is a kitchen appliance that uses microwave radiations to quickly and efficiently heat or cook food. Actually, microwave oven is a um, embedded kind of project because it contains a microcontroller. It controls its operation, including heating, timing, and user interface function. Actually, there are several modes in various microwave ovens. Actually, we are going to implement four modes as follows. First, micro mode, grill mode, convention mode, and start mode. Actually, four modes that used in microwave oven. We'll discuss about that deeply. Actually, micro mode. Actually, what we want to know what is micro mode. It is used for defrosting or gently reheating food items without overheating or overcooking them. It uses maximum power of 900 watt. Overheating or overcooking the food is not good for health. So, as a process of micro mode, in this mode, the maximum time that can be set for cooking will be 60 minutes. Next, we'll see what is grill mode in microwave oven. The grill mode in a microwave oven is used for cooking or heating food with the additional features of browning or crisping the food surface. This mode is useful for preparing dishes like toast, kebabs, and grains. Ah, Next, we'll see about what is convection mode. The convection mode in microwave. The convection mode in a microwave oven uses a fan and heating element to circulate hot air, enable it to bake, roast, and cook food evenly. In this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. This mode is used for baking, roasting, and generally cooking food items that require even consistent heating for all dishes. Right? It's used in convention. The basic requirements of our project: MPLAB IDE software, XE8 compiler, PICSIMLAB simulator, a PIC16F877A microcontroller and 16x4 LCD and tactile switch and matrix keypad called as MKP and timers. What, Next we'll see what difference between microcontroller and microprocessor. A microcontroller is a chip optimized to control electronic devices and it is specially designed circuits for embedded application and is widely used in automatically controlled electronic devices. Microcontroller is a device with a single chip consists of memory unit, processor, and input-output device. And microprocessor is a controlling unit of microcomputer. It wrapped inside a small chip. It performs an arithmetic logic unit operations and communications with the other devices connected with it. It is a single integrated chip in which several functions are combined. Next, uh, character liquid crystal display called as CLCD. A character LCD is commonly used to display alphanumeric characters and symbols in various electronic devices. In PICSIMLAB, we have two types of display that we used: 16x2 display and 16x4 display. There are two types of communication modes in character liquid crystal display: 4-bit mode and 8-bit mode. MKP, actually, yeah, matrix keypad is called as MKP, and matrix keypad is an input device that allows user to enter data or make selection by pressing buttons arranged in rows and columns, and it works by detecting the unique row and column intersection of the pressed button to identify the input. It's called matrix keypad. A matrix keypad is typically made by arranging individual tactile buttons in a grid pattern. Tactile switch are small electromechanical devices that are designed to be mounted onto a printed circuit board called PCB. It provides tactile feedback to users when pressed, giving a noticeable physical click or resistance sensation. It's typically used in keyboards and buttons. It's called tactile switch. Interrupts. Interrupts are mechanisms that allows the processor to temporarily pause its currently execution of instructions to handle specific events or external signals. They are used to efficiently respond to time-sensitive or high-priority tasks such as input from sensors, communication requests, or real-time events. Interrupts play a significant role in multitasking and multi-threading environments. They allow the operating system to efficiently switch between tasks or threads, ensuring fair allocation of resources. ISR. ISR stands for Interrupt Service Routine. It is a specific subroutine or function in a computer program that is executed in response to an interrupt. ISRs are a fundamental concept in real-time and embedded systems, allowing them to respond rapidly to external events. Where an interrupt occurs, such as a hardware event or a software-triggered event, the processor jumps to a corresponding ISR to handle the interrupt. It must be terminated with the instruction RETFIE. It stands for Return from Interrupt. It is an instruction used in code. Timers. Timers in microcontrollers or hardware modules is used to measure time intervals, generate precise timing signals, or trigger events at specific time intervals. Timers consist of counters and control registers that allows for flexible timekeeping and event management in embedded systems. It counts up or down based on a clock source triggering events or interrupts when it reaches a preset value. We have used watchdog timer in our PICSIM project. Next, my friend Vishnasan will explain about architecture and what and project demonstration.
Once again, a warm welcome to everyone. My teammate explained the various peripherals used in our project. Now you can see the pictorial representation of the PIC16F877A microcontroller and the peripherals used in the PICSIMLAB. I2C and RS-232 protocol, which is also a form of serial communication. It was the most used form of data transmission once a time. And EEPROM, where you can store critical data up to 32 kilobits, and RTC, real-time clock, and LM35 temperature sensor, analog to digital converter, character crystal liquid display, and matrix keypad, buzzers, LEDs, etc. While going to the microcontroller part, the PIC16 F877A microcontroller board is a versatile development platform based on the microchip uh, PIC16 F877A microcontroller, which offers a wide range of peripherals for various projects. Now I will show you the demo of our project. While coming to the implementation part, this is the source code we have used for our project. Uh, let's build this code. We have built successful. Now we can go to PixelLab and let's load the hex file, microwave hex, and the machine gets powered on. And when we press button 1, it starts micro power 900 watts. And we are going to set the timer as 10 seconds. When we press hash, it will start, and when we press clear, it just gets clear. Set the timer to 10 seconds, and let's start. We can also pause the timer by pressing 5. We can also start by pressing 4. And then second mode is grill mode. When we press this, we are giving this timer to be 10 seconds and press enter. When we press 4 again, 30 seconds get added up to the original time. And we can pass it to, and when we press stop, it gets returned to the original name. And third mode is convection mode. I'm giving the temperature as 250 degrees Celsius, 50 degrees. Actually, the original time to it takes for preheating is 180 seconds, which is 3 minutes. But for our convenience, we have converted it to 18 seconds. And now we can set the timer to 5 seconds or whatever the time the user needs. And the fourth mode is start. It actually starts the mission with a predefined timer, which is 30 seconds. The same functions can be applied here. We can pause it, can pause it, we can resume it, we can stop, and that's it about our project. Uh, it was a wonderful experience working with Emertxe. It helps us to develop our knowledge in embedded C, and we hope this finds useful for everyone.